All right, here's the video guide for lesson 10.2.2. It's a deeper dive into probability, some review of some of the older probability we've done, some review of the conditional probability like we did last Thursday, and then an introduction to this new idea of a two-way table, which is just really a way that we can collect data or organize our data and then do probability based on the table. And we'll see that in the last problem of the day. But with that said, we'll just get right into it. And look at this first problem. Crucial to read this first problem really closely. I have some of it highlighted even because to set up what we need to set up, we need to be really careful on what it says. And so I'm going to read it here just to even make sense of it for myself. It says, in the child's game Build a Farm, each player first spins a spinner. Half the time that spinner comes up red and half the time it comes up blue. So that's kind of like our first event happening. Now after that first event, if the spinner is red, the player reaches into a box. If the spinner is blue, the player reaches into a blue box. The red box contains 10 chickens, 10 pigs, and 10 cows. And the blue box contains 5 chickens, 4 pigs, and 1 cow. So we have a lot going on there. The first event is just spinning for red or blue. And then the second event is reaching into this box, with either red box or blue box, and just picking out one of these counters or one of these animals at random. And we're going to organize this first with a tree diagram. All right. For A, B, and C, I'm going to put it on a different slide here because I just need more room, especially for this tree diagram. And so I'm going to be flipping back and forth here for a little bit. But let's take a look at what this says here again. So half the time it lands on red and half the time it lands on blue, and that's going to be our first event. And so I'm going to say this is A here. The first thing that happens is that half the time it lands on red, half the time it lands on blue. That's that first event right there. And that's how we would make it with the tree diagram. Okay, now we'll branch off into the red category first, and then we'll do blue after that. But what happens if we say we do spin a red, then we get to reach into the red box, right? And that red box contains 10 chickens, 10 pigs, and 10 cows, or in total it contains 30 pieces. All right, and you have a 10 and a 30 chance to get chickens, you have a 10 and a 30 chance to get a pig, and you have a 10 and 30 chance to get a cow. And so that's how the branches are going to work. Say you got a red, now it branches into chicken, pig, and cow. And 10 out of those 30 times you get a chicken. We could probably reduce that down to 1/3. I actually am going to reduce that down right away to 1/3. 10 over 30 is the same thing as 1/3. You have a 10 and 30 chance, or 1/3 of a chance for a pig, and you have a 1 1/3 chance for a cow. So now we have our tree diagram. Say we spun red and then got pig, we would just multiply down those branches and we'd have our probability for pig. We've done this before in chapter 4 when we first did probability. All right, so that's the red path, but let's go down blue path now. If we go down the blue path, you can have 5 chickens, 4 pigs, 1 cow, or in total there's 10 total pieces in there. 5 out of those 10, or half of them, are chickens. 4 out of 10 of them are pigs, and 1 is a cow. So we'll make my branches here. Again, it's still chicken, pig, cow. So chicken, pig, cow. And it said what, 5? So 5 out of the 10 pieces were chickens. Yep, 5 out of the 10 pieces were chicken, 4 out of the 10 were pig, and 1 out of the 10 were cows. And so for cow, we'd have a 1 in 10 chance for a cow. We'd have a 5 in a 10 chance for chicken, but that's really 1/2 the time it's chicken. And then for a pig, it would be 4 out of 10 times you would get a pig, but that reduces down to 2/5. So I'm going to change that right away. And now we have our tree diagram, and we'll use it again here. But really what this tree diagram is saying is the first event, you either get a red or a blue, and it splits 50-50. If you land on, if you spin red, then you have a 1/3 chance to get chicken, pig, or cow. If you spin blue, which happens half the time, you have a 1/2 chance for chicken, 2/5 chance for pig, and a 1/10 chance for cow. So really you want to spin red. Red is a lot more consistent. But let's keep going here. We could talk about probability forever. All right, so now it's saying, what is the probability of getting a cow in one turn? And it doesn't specify saying we need to get a red cow or a blue cow. It's just saying cow in general. And so we got to follow both ways that you can get a cow and add those two probabilities together. So one way you can get cow is the red route. You could do 1/2 probability and then down the 1/3 line to get a cow. And so you multiply down your branch. And so 1/2 times 1/3 will give us that probability. So 1/2, this is for part B, sorry. 1/2 times 1/3 is, you multiply on the top, multiply on the bottom, 1/6 for following the red path. And then to follow the blue path, you would have that 1/2 and then the 1/10. So we got to multiply those two down that path. So 1/2 times 1/10. And sorry, that 10 looks bad. And multiply top, multiply bottom, you get 1/20. And so those are the two chances. That's how you would spin cow. That's the probability for getting cow. But we need to add those two together. And so we need to 1/6 plus 1/20. We got to get a common denominator here and then add them together. Most common denominator, the smallest common denominator we can get here is going to be a denominator of 60, which means I got to multiply this one by 10 and multiply this one by 3. And so this is 10/60ths plus 3/60ths. And then my probability of getting a cow is just this added up, which is 13/60ths. And that's my answer for the probability of getting a cow in this farm game. And again, all I did was I multiplied down my branch to find the probability of getting it down the red route. I multiplied down my branch for the probability of getting cow down my blue route, and then I just added those together, adding fractions, common denominators here. All right, we'll keep moving. And we'll get into part C here. And it says, even though the events, the spin and the animal counters are not independent, a modified area model, as shown here to the right, this is our modified area model, is possible for this situation. We're going to copy it and then verify that the probability of cow is the same thing as you found in part B. So actually, I'll do part C here, but the same thing is going to show up here. And so I'm going to highlight here, grab my highlighter. Because we're looking for cow, and the probability of winning in this event for B was that you would get a cow in one turn, we would have to talk about that section right there and this section right here being winners. And like we did in an area model, you kind of just multiply in your boxes here. And so you want blue cow, you have to multiply 1/2 and 1/10, which we did before already, but we're going to do it again. 1/2 times 1/10 is 1/20. And then to get the cow up here, you'd have to do 1/2 times 1/3, which is 1/6. And so you'd get the 1/20 plus 1/6 again, which would be the same thing, 13/60ths as before. It's just a different way. Instead of doing it on a tree diagram, they're using this, modified area model. Same thing as a regular area model, though. If you want cow, you have to multiply in blue and cow. If you wanted blue and chicken, you'd have to multiply blue and chicken to get chicken. And we'll kind of investigate that more with D down here, actually. And so in part D here, it says, now we're going to investigate some conditional probability. So we're going to investigate the conditional probability that the child's spin was red, given that you know the child got a cow counter. All right, so we're going to use, it changes our sample space. So we'll just keep going with what it says here. Since you know that the child got a cow counter, the new sample space is limited to only the outcomes that contain cow, which is the area that you shaded in part C. I had it shaded but erased it, so I'm going to shade it again. We're limited to this new sample space of just cow here because we know that they got they got a cow. We just want to figure out what the probability would be that, or it would be that they got red with the cow. So now consider the outcomes that contain cow. What is the conditional probability that a child spun red, knowing that the child got a cow counter? So we got to first talk about what our new sample space is. And our new sample space is everything that contains cow, or this 13/60th. What we're going to do here is we're going to do, for conditional probability, we're going to take our whole sample space, the total chance of getting cow, and then we're going to put the chance of red cow, the specific red cow above it. And so our total probability here for getting a cow is 13/60. You have a 13 and a 60 chance that it's going to be cow. And then that's going to be in our denominator because that's the new sample space. That's the probability of getting cow. And then in the numerator, we're going to put the chance that it is specifically a red cow. And if we're talking about a red cow, it's 1/2 times 1/3, which is 1/6. And so you end up with 1/6 over 13/60ths. And then we need to reduce this down. We're talking about dividing fractions here. And the best way I think about dividing fractions is this method I call keep, change, flip. You keep the numerator, you change your division to multiplication, and you flip the denominator. And so this becomes 1/6 because I keep the numerator, change the division to multiplication, flip the denominator, so now it is 60 over 13. And we just multiply across now. All right, and if we multiply here, I've already done this. This actually reduces down, and this becomes 10/13. 1 times 60 is really, 60, and 6 times 13, 1 second, let me grab my calculator here again. 6 times 13 reduces down to, or it multiplies to be 78, and then you could divide the numerator and denominator by 6, and you would come back to that 10/13 as your answer. And then that would be your conditional probability. Given that you know it's a cow, and you want to figure out the probability that it was a red cow. We're going to do the same thing for part E here, the conditional probability that you got a pig, knowing that your spin was blue. So what we're going to do again, we're going to put our entire sample space in the denominator with blue pig in the numerator because that's the specific one we want. And so I'm going to highlight, first erase what we were doing up here with the cow, and now we're going to be focusing on, we know that the spin was blue, and so we have all of these possibilities here because we know that the spin was blue, and so our denominator is going to be sorry, I think I misread this here, so I'm going back, and I think it's saying to find the conditional probability that you got a pig knowing that your spin was blue. Or I think it's actually, sorry, again, I think you know you got a pig, so we want to figure out what the chance was that the spin was blue. So it's really similar to what we were doing with D. So it's not we know that the spin was blue, we actually know that they spun, or that we know that they got a pig, and we're going to try to figure out what the probability is that was a blue pig. And so we got these probabilities right here from both the pigs, and then we're going to focus in on that blue pig in particular. And so we're talking about the whole sample space, the whole chance of getting a pig. You have to do 1/2 times 1/3, so 1/6. 1/6 from red pig. And 1/2 times 2/5 from blue pig, so 1/2 times 2/5 is 2/10, which reduces down to 1/5. So 1/6 plus 1/5 is your total chance of getting a pig. With common denominators, I believe this becomes, you have to multiply top and bottom, so I think our common denominator is going to be 30 here. This is going to be 6/30ths, this is going to be 5/30ths, which makes this 11/30ths. And then that's going to be our denominator because that is your total probability of getting a pig. And then we're going to put in the numerator the specific probability of getting a blue pig. And so the specific probability of getting a blue pig is the 1/2 times 2/5, which is the 1/10 again. And so, or sorry, 1/5. And then again, it's going to be a keep, change, flip, so we could actually divide these fractions. You get 1/5 times 30 over 11, keep, change, flipping it, and then multiplying out here. This actually, I know, reduces down right away to 6 over 11. And that is your probability right there. That is your probability that the you spun blue knowing that you got a pig. All right, just more examples right there of conditional probability, a little bit more in depth, and we'll see it again on the next problem, a little bit more in depth than we were doing Thursday, just because we have these bigger fractions and working with these fractions. I'm going to pick up with 74 and 75 in the second video.